Thank you, Dr. Orbach. And let me just say what an honor it is to be invited to participate in this panel and with this distinguished group at this meeting. It's truly an honor. It is an exciting time. As Dr. Orbach mentioned, I've been doing wind energy for a number of decades. We had the annual American Wind Energy Association meeting in Texas in Dallas last year, and there were over 20,000 attendees at that meeting. It was truly remarkable. I can remember when it was a few people, maybe 50 or 60 sitting in a room. Texas, let me get started with the slides here. We're a leader in the nation in wind energy, and most people are aware of that. What I'd like to cover in the next few minutes is how do we get to be a leader, and will we remain a leader? What innovations are there? And I'm going to pull out a few here that actually aren't scientifically based. They're really in the public policy arena. But of course, it takes public policy as well as technology, science, all moving together to do this. We are presently doing wind energy at about 10% of the installed capacity, a little bit over that for the entire generating capacity for the state of Texas. That's a huge amount of installed capacity. In March 2010, wind power delivered a one-hour record of 25% of the ERCOT, the Electric Reliability Council of Texas, load demand. So literally, for most of the people in this state, they were getting 25% of their energy from wind energy during that one-hour block. The annual average is closer to about 8%, but at that particular time, it was literally about a quarter. And I point out that in 1995, there was virtually no wind energy installed in the state of Texas. So what's going on? What's the story? Well, the first thing you realize when you look at a wind map, and the darker brown colors there on that map represent the more energetic areas, you see the Great Plains is where this is all happening. And the darker colors in the southern Great Plains, and especially Texas, show you one reason: we have the resource. You'll note just to the west of the Great Plains, of course, you've got the Rocky Mountains, very, very good wind resources, but hard to install wind turbines. So the play really is what we call the wind corridor from Texas to North Dakota. If you go back to 1995, a colleague of mine, Rick Walker, worked for Central and Southwest. He's now at Texas Tech in our wind energy group. He installed a small R&D facility with Central and Southwest in the Fort Davis area. The first utility scale in the state was in the Delaware Mountains, Guadalupe National Park, a 40-megawatt facility constructed by Tenatech and partners of the Lower Colorado River Authority and the city of Austin. As these came to come online, people said, well, this is interesting. What do the people of the state think about this? So the utilities did some deliberative polling. And according to Rick, who was in the utility industry at the time, there was a big surprise when they found that people, to a large fraction of the folks in the state, were very interested in renewable energy, especially wind power, and were willing to pay more to have it available to them. And that's what this poll showed back in the 96-97 timeframe. In 1999, the state picked this up. I don't have this on this slide, but there was the first renewable portfolio standard put in Senate Bill 7. After that occurred, General Electric came on board as one of the major utility players in the state, in the nation, to get involved, and the first large wind farms were installed in the McCamey and Abilene area. Then in 2005, the Texas legislature initiated Senate Bill 20. They expanded the renewable portfolio standard, which is a standard mandating that the state begin and the utilities in the state begin to introduce renewable energy. And they put in place what was called the competitive renewable energy zones, okay? And this was a system, and I'll show you the map in a second here, to move energy from the wind-rich regions of the state to the population centers. They're not co-located. The wind is in West Texas. The people live mostly in Central Texas or on the Gulf Coast. They also established a 10-gigawatt goal in 2005. We've already passed that goal 15 years early. These CREZ zones you can see here, okay, and let me point it out on the map, okay, were identified in that Senate bill as areas where you could access transmission, and also that these are very highly energetic areas, and You might also know that ERCOT really is this part of the state, the Electric Reliability Council. This is actually part of the eastern grid here in West Texas, and far West Texas is actually part of the western grid. So Texas actually has all three grid access. They're not electrically connected except through some DC links. So this bill proposed moving energy from these very energetic areas here to the population centers, actually in a different grid. So it'll be interesting to see how that plays out as time goes on. This is actually where the proposed lines are in order to move that energy. The dark red areas here are the lines, and again, you can see these competitive renewable energy zones here and the ones up here in West Texas, again, to move the power to the load centers. If we take a look at this growth, you can see here in the couple of points back here, I brought out 95 when things first started, 99, the first RPS. The growth started quickly, 05, Senate Bill 20, and then we have exponential growth. The last number here is just through half of the 2010. Didn't have all the latest data to include. So where are we headed in the future? First of all, the growth this year will be reduced over what it's been in the last few years, mainly because of the recession. This is a very capital-intensive industry, as one might imagine, and so the growth will be reduced. The other reason there's going to be reduced growth is that there is simply not enough transmission in the state in order to move this energy. In 07, about 1% of the wind energy produced was curtailed. In 08, it was 8%. In 09, it was 17%. So you literally were able to produce 17% more energy, couldn't get it to load because you just didn't have the transmission. The CREZ process, however, is well underway to address this, and that, in fact, is what I'm going to call the innovation here, really moving forward with this. We are leading the country with this competitive renewable energy zone idea, finding these energetic areas, figuring out ways to move that power to load centers. The ratepayers of ERCOT will be paying for that. It's a $5 billion investment. But that combination of finding the resource, identifying, and then moving that power is what's really setting the stage for the future. What is the impact of this? Well, I went to a recent report from the Perryman Group where they forecast the impact of the CREZ lines on the state. It's an 18 gigawatt build out. It's not only going to have to be wind. They've made it open source, but there's a lot of numbers here, but let me just give you two takeaways. As a minimum, they estimated the equivalent to be equal to the air transportation industry in this state, as a maximum to the computer and electronics industry as far as the economic impact on the state. Truly for me anyway, some remarkable numbers. Secondly, there'll be significant reductions in CO2 and nitrides, NOx emissions. Thirdly, thermal power plants use a lot of water for cooling, and the wind energy doesn't use any water. In a state like Texas, where water is an issue, saving water is a big deal. About 17 billion gallons of water a year, that's about 30% more than the city of Lubbock uses, would be saved with this. So certainly this has the potential for a huge impact on the state. Opportunities, I'm going to go with what Dr. Holders mentioned here, which is integrating natural gas and an intermittent resource like wind together in a way that has to be considered from a system point of view. I think there's a huge opportunity there and a lot of work to be done. Wind forecasting is tough business. It's hard to even get the temperature right tomorrow, much less what the wind is going to be at 2 o'clock in the afternoon. Wind goes as a function of the cube, so getting these numbers right is very important. We're going to really have to move forward in wind forecasting technology, and that'll have other benefits also. Also, the implementation of storage, that 17% that we couldn't send because of transmission. If we had on-site storage, you could address some of that issues. And lastly, I mentioned that wind is typically generated at night in the Great Plains due to the nocturnal low-level jet. And if we can have a robust plug-in vehicle situation with a lot of vehicles being charged overnight, essentially you'll be charging those with wind power. Barriers, I see two. One, first, the inertia of the system. This was built really as a thermal generation system set in place decades ago. How to make it compatible for thermal generators as well as intermittent generators like solar and wind is going to be a real challenge. I think the smart grid, as other speakers today have mentioned, I think is going to be very important. And I'm going to finish up my last few minutes talking about workforce and education, which I really also see as a barrier. DOE projects that if we're going to have 20% of our energy from wind, these are the kind of people we need to drive this industry, about 180,000 direct employees in those various categories. We decided to take a look at that at Texas Tech, brought some economists in to say how many of these people need four-year degrees, graduate education, et cetera. We know there's a lot of windsmiths that are needed to climb towers. We came up with these numbers, about 20 to 25,000 people over the next 20 years to keep this industry moving forward. As a result, we teamed with the Workforce Commission in Texas. We established the Texas Wind Energy Institute to help address this. We partnered with Texas State Technical College. 1 minute, or am I done? Finished. Okay, 2 slides left here. And that is a partnership. They're focused on 2-year, and we're focused on 4-year. We're also partnering with the Wind Alliance in Houston to access both collaborating with other academia and industry here in Texas. And my final slide is that we're looking at graduate and undergraduate education. There's a real need. We're building on a 40-year history at Texas Tech. Kishore Mehta, one of the members of this group, has been there the whole time to do that. We have the only PhD in the multidisciplinary area of wind science and engineering. We're looking at actually building a Bachelor of Science in Wind Energy. We have currently about 100 students enrolled and a very active student organization. So we see a very bright future, and thank you for your time.